Chapter 5 Review Questions. Question number 1. Look at this reaction. NaOH plus HCl gives NaCl and H2O. Which type of reaction is it? So if you look at the reactants, you have sodium hydroxide, which is a base, and you have HCl solution, which is hydrochloric acid. So this one is acid. And you know that the reaction of the acid and bases is called neutralization reaction. Part B, it is exothermic. What does that mean? The exothermic reactions are the reactions that releases the energy. So by neutralizing NaOH with HCl, the energy is given out. Part C, what will happen to the temperature of the solution as the chemicals react? Because this is an exothermic reaction, by mixing these two solutions and by reacting, the temperature of the solution increases because it releases the energy to the solution. Part D, draw an energy diagram of the reaction. In this reaction, we had two solutions. One of the solution was NaOH and another solution was acid, hydrochloric acid, HCl. And when we mix these two solutions, the reaction happen. If we have thermometer inside this solution, we can see that the temperature increases because the reaction is exothermic and it releases the heat to the solution. We reach to here, part D, draw an energy diagram for these reactions. In the energy diagram, we have two axes. The y-axis is the energy and the unit is kilojoule or kilojoule per mole, and the x-axis is time or reaction progress. This is an exothermic reaction, so the energy level of the reactants are more than the energy level of the products. So if the reactants are here, NaOH and HCl, the product would be at the lower energy level, NaCl and H2O. And this difference is the energy which releases to the environment, particularly the solution, by the reaction. So here we have energy out. Question number 2. Water at 25 degrees was used to dissolve two compounds. The temperature of each solution was measured immediately afterwards. So one of the compounds are ammonium nitrate. Ammonium is NH4 plus, nitrate is NO3 minus. So the compound is NH4 NO3. And the other one was calcium chloride, CaCl2. After mixing these two compounds with the water, the beaker which the ammonium nitrate was added to that, the temperature changed from 25 to 21, and the beaker which calcium chloride was added to that, the temperature changed from 25 to 45. Now let's look at the question. It says list the apparatus needed for this experiment. So obviously for this experiment we need a beaker which contains the water, and we need these two compounds, and we need a spatula or spoon or something that we add these compounds which are solid to the water. And also, more importantly, we need the thermometer because we want to measure the temperature change. Part B says calculate the temperature change on dissolving each compound. So when we want to find the temperature change or any change, we can show it by the delta T. T represents temperature, then delta means change. When we want to find the change in any quantities, we measure the final value minus initial value. So the final temperature minus initial temperature give us the temperature change. For the first one, which we are adding the ammonium nitrate, the final temperature was 21, while the initial temperature of the water was 25. So the delta T for the first compound for the ammonium nitrate for NH4 NO3 is final temperature 21 minus initial temperature 25, which becomes negative 4 degrees centigrade. So this negative sign here shows that the temperature has decreased after you're adding ammonium nitrate to that. For the second compound, for calcium chloride, the final temperature was 45. Initial temperature of the water was 25. So the temperature change is positive 20 degrees. Again, this positive sign shows that the temperature has increased upon adding CaCl2 to the solution. Part C, which compound dissolve exothermically? So if any process is exothermic, the temperature of the surrounding increases. So here we can say that dissolving calcium chloride is exothermic because the temperature has increased. How did you decide this? As I said, because the temperature of the water has increased, it shows that the reaction was exothermic and it released the heat, or it released the energy to the solution. Part 3, what can you say about the energy level of its ions in the solution compared with its solid compound? Okay, I want to explain a little bit about this question. When you dissolve ammonium nitrate or any ionic compound, so I have NH4, NO3, ionic compounds are solid, as you know. When you dissolve them in the water, the cation and anion separate from each other, so it becomes NH4 plus. This is the cation, and I write aqueous, it means it has dissolved in the water, and the anion is NO3 minus, and it's aqueous. So this is the process of the dissolving an ionic compound inside the water. So here it asks, what can you say about the energy level of its ions in the solution compared with in the solid compound? So the energy level of the ions inside the solution, aqueous, compared to the ions inside the solid compound. Because this reaction was endothermic, the temperature is negative, the temperature change is negative and the temperature is decreased, it shows that the energy level of these ones are higher than the reactant, because in the endothermic reaction the energy level of the products are higher than the energy level of the reactants. But this question asks about the other compound, about the compound which it dissolves exothermically, and that is calcium chloride. Okay, same as ammonium nitrate, calcium chloride is solid, it's an ionic compound. When we dissolve it in the water, cation and anion separate from each other. So cation is Ca2 plus, aqueous, to show it has dissolved in the water, and it has two chloride ion, aqueous. Because this reaction is exothermic, the energy level of the products, the ions in the solution, would be lower than the energy level of the reactant, the ions inside the solid compound. So if I want to draw the energy level diagram for the dissolving. For the first one, which is endothermic, I can draw it like this. So I don't draw the energy and the extent of the reaction. This is the energy level of the reactant, which is solid NH4NO3. When it becomes ions dissolved in the water, the energy of those ions increases because the reaction is endothermic in this case. For this one, if this is the energy of the ions in the solid CaCl2, the energy level of the ions inside the solution would be less than that one because the reaction is exothermic and the energy releases here. And for the first one, the energy absorbed or taken in. Okay, the question doesn't ask us to draw the energy diagram, but for more clarification, I draw the energy level diagram for that one. Part D of this question, for each solution estimate the temperature of the solution if the amount of the water is halved, but the same mass of the compound is used. So here, if we are adding the NH4NO3 to the water, but the level of the water is half of this one, what happens to the temperature of the water? So you can see for the first experiment, the temperature drops from 25 to 24. So 4 degrees centigrade, the temperature has dropped. But if you half the water, the temperature of the water which drops doubles because at the beginning you are taking the energy from this amount of the water. Okay, it is endothermic. Dissolving takes the energy from the water. But if you halve the water, the same amount of energy must be taken from a smaller amount of the water. So it means you take more energy from that small amount of the water and the temperature change increases. So the temperature, instead of decreasing only 4 degrees, it decreases more. Part 2 says the same mass compound is halved. The mass of the compound is halved, but the volume of the water is unchanged. Okay. For example, for the second one, if we have same amount of the water, but we add half of the original one, so less amount of the substance dissolve in the water, so it releases less amount of energy because we half the amount of these salt or ionic compound, the amount of energy which releases also becomes halved, cuts in two. So that's why the temperature increases. For the original amount of the salt or ionic compound was plus 20, but if we half the amount of the ionic compound, the temperature would be positive 10 degrees. So only 10 degrees increases because the amount of energy which releases also cuts in half. And for the last part says both the mass of the compound and the volume of the water are halved. So if we cut the mass of the compound, the amount of energy which releases also halves. If we halves the volume of the water, the amount of energy which added to that half volume of the water would be the same amount of the energy which adds to the whole amount of the water. So the temperature change doesn't change. The same temperature change you will have for NH4NO3, the temperature drops 4 degrees. For CaCl2, the temperature increases 20 degrees. So to summarize the answer, for part A, the amount of the water is halved, but the same mass of the compound is used because we are using the same mass of the compound, so the amount of the heat energy which releases to the water or absorbed to the water is the same as before, but because the half water is halved, if we add the same amount of energy to the water, but the volume of the water is halved, the amount of energy which receives per volume of the water doubles. So the temperature increases for calcium chloride twice as the original one, it becomes positive 40, and the temperature which drops for ammonium nitrate would be twice as the original one, becomes negative 8. For part 2 says the mass of the compound is halved. So when you halve the mass of the compound which you are dissolving in the water, the amount of the heat which releases to the water in exothermic reaction also halves, and the amount of energy which you are taking from the water in endothermic reaction is also halves. But the volume of the water is unchanged. So if you cut the mass of the compound which you are dissolving in the water without changing the volume of the water, the temperature change also cuts in half. So in this case, the temperature for the ammonium nitrate drops only by 2 degrees centigrade, and the temperature which increases for calcium chloride increases by 10 degrees centigrade only, because you are adding half of the original amount to the water. And in the last one says both the mass of the compound and the volume of the water are half. So when you cut the mass of the compound, the amount of energy which releases to the water and or absorbed from the water also cuts in half. But because you are cutting the volume of the water also, and the volume of the water also halves, the temperature change would remains the same, because you are adding half of the original heat to the half volume of the water. That's why the temperature change remains positive 20 for exothermic reaction, and for the endothermic dissolving, you are taking half of the original energy from half volume of the water. So the temperature of the water also changed by negative 4.